When I introduced you to the ANOVA, I said that it's kind of like a t-test, but supercharged for dealing with more variables. Well, a regression analysis is kind of like a correlation analysis, but supercharged for looking at more variables. So, a regression naturally follows from a correlation analysis. Now, the difference between an ANOVA and a regression is that you use an ANOVA when the independent variables are categorical, like days of the week or snack food type, and you use a regression when the independent variables are continuous. Now, regression is actually a little bit more flexible than an ANOVA. So in a regression, you can have both continuous and categorical variables, but if at least one independent variable is continuous, then you're going to use a regression instead of an ANOVA. So let me give you a few examples. In fact, this is one I've already introduced you to earlier in the course. So let's say we want to figure out how tall someone is, and we want to know if their height is related to or is predicted by their sex, their parents' height, and their childhood nutrition. So here you can see there's three variables that we have here. So we cannot compute a correlation. If we just wanted to know how is your height related to your parents' height, these are two numerical variables and we could easily compute a correlation. We wouldn't need a fancy regression analysis. But here we have multiple variables, some of which are numerical and continuous, and one of which is categorical, that would be sex. So here we are going to be using a regression. Here's another example of a regression. Here's our research question. Do students' grades on a statistics exam depend on how much that student sleeps, how much the student studies, and the interaction between sleeping and studying? So we might get a regression model, an equation that looks like this, where we're trying to explain how well students are doing on their statistics exam based on how much they sleep, how much they study, and the interaction between them. So the interaction between these two factors might mean that when people are getting enough sleep and they are studying a lot, then they really do well. But if you're studying a lot and you're not sleeping enough, then you're still not going to do very well. That would be an example of an interaction between sleeping and studying. Now, similar to the ANOVA, with a regression, we also get a table of numbers, and it also can look a little bit complicated and a little bit intimidating at first. And also similar to the ANOVA table, there's a lot of information, there's a lot of detail in these regression tables, but the two most important columns to focus on are the leftmost column where we list the factors, and the rightmost the p-value column, which is sometimes all the way on the right, but sometimes there's other information to the right of it. So again, just focus mainly on the names of the factors of the different independent variables and on the p-value. Now, sometimes in a regression table, you will see a row for the constant, or sometimes it's called the intercept. Usually you can just ignore this term. That basically just means that the data are different from zero. In our example, we're looking at exam scores, so the average exam score is different from zero, hopefully. So the constant is going to be statistically significant. So we are mostly interested in these variables and their corresponding p-values. Also, like with the ANOVA, this p-value just tells you that the factor is significant. It doesn't tell you how exactly the number of hours relates to the exam score. To understand that, you would need to dig a little bit deeper into the numbers, and you would also need to visualize the data.